In this video, we're going to look at the domain of radical functions. In 1, it says, solve each inequality and state the answer in interval notation. In A, we have 3x plus 4 is greater than or equal to 0. So the first thing I'm going to do is subtract 4 from both sides. So I have 3x is greater than or equal to negative 4. And now we'll divide both sides by 3, and we get x is greater than or equal to negative 4/3. And then in interval notation, if we have to be greater than or equal to negative 4/3, negative 4/3 is the smallest value we're going to have for x. So we have bracket because we're including it, negative 4/3 to infinity. In B, we have 4 minus x is greater than or equal to 0. So we're going to add x to both sides, and we have 4 is greater than or equal to x, which means that x is going to be less than or equal to 4. So we're going to have from negative infinity to 4, and again brackets around 4 because we can include it. In C, we have negative x minus 5 is greater than or equal to 0. So we're going to add x to both sides, and we get negative 5 is greater than or equal to x, which means that x is going to be less than or equal to negative 5. So we have negative infinity to negative 5. And in D, we have negative 2x plus 3 divided by 7 is greater than or equal to 0. And the first thing I'm going to do is multiply both sides by 7, and I get negative 2x plus 3 is greater than or equal to 0. And now I'm going to add 2x to both sides, so I have 3 is greater than or equal to 2x. And now we're going to divide both sides by 2, and we get x is less than or equal to 3/2. So in interval notation, we would have from negative infinity to 3/2. In 2, it says, based on your knowledge of square roots, answer parts A through D. In A, it asked, is the square root of negative 25 a real or a complex number? And this is a complex number. Remember, the square root of negative 1 is I, so we would have 5i is the square root of negative 25. And B, it asked, is the square root of 25 real or complex? And this is a real number. It equals 5. And C, it asked, if the radical represents a real number, is the radicand positive or negative? And if the radical represents a real number, then the radicand is positive. In D, it asked, does the radicand have to be greater than 0 or less than 0? Can it be equal to 0? So we can answer this by saying that we have to be greater than 0, but it can also be equal to 0. So we can say that the radicand has to be greater than or equal to 0. The domain of a square root function, s of x is equal to the square root of h of x, is the set of all real numbers that satisfies h of x being greater than or equal to 0, which is what we just talked about in D. In 3, based on your response to problem 2, find the values of x that yield real values of y for the following. Find the domain of each. State the answer in interval notation. In A, we have y is equal to the square root of 3x plus 4, which means that 3x plus 4 has to be greater than or equal to 0. And above, in 1a, we found that the solution to the inequality was negative 4/3 to infinity for 3x plus 4 being greater than or equal to 0. So we're going to have the same down here, negative 4/3 to infinity, which represents the domain of y is equal to the square root of 3x plus 4. In B, we have y is equal to the square root of negative x minus 5, and negative x minus 5 would have to be greater than or equal to 0. And above, we found that negative x minus 5 is greater than or equal to 0 from negative infinity to negative 5. In 4, it says find the domain of y is equal to 1 over the square root of 3x plus 4 and state the answer in interval notation. Now the difference between 3a and 4 is that our radical is in the denominator in 4 and it was in the numerator in 3a. So now we can't have our inequality equaling 0. So we're going to just say that 3x plus 4 has to be greater than 0. And so the one value that changes for the domain of 4 from 3a is now we cannot include negative 4/3. So we're going to have negative 4/3 and parentheses, because we're not including it, to infinity. And that's all for this video on the domain of radical functions.